Welcome everyone, and thank you for joining us. I'm Brenda Dentinger from BIOPAC, and I will be your moderator on today's webinar. Brain Research, Startle and Prepulse Inhibition. We are going to show you how to get started with this type of research, and also we'll talk about best practices if you're already familiar. We have a wonderful speaker today. I'm excited to introduce Tim Cook. He is a product expert and domestic sales manager at BIOPAC. Tim has his master's in science in health and human development, and he has over 21 years of experience in the life sciences and physiology monitoring industry. He's very well versed in guiding customers and setting up their labs, and also has a ton of great information to share. Welcome, Tim.
Good morning.
All right, Tim, I'm going to go ahead and make you presenter. Let's get started.
Perfect. Thanks, Brenda, and thank you everybody for joining us today, especially with kind of the start of semester over the last week or two. Taking time for this thing is probably a little bit challenging, so we do appreciate that. And just a couple of fun numbers or facts that we always like to draw a little bit of attention to is that obviously BIOPAC, we've been in business and a leader in the life science research industry for over 35 years now, and are proud to say that over 99% of top universities utilize BIOPAC for their research efforts. And generally, when you walk on any campus, that's not beholden to just one department, but generally you can find us in numerous departments throughout campus. So that's always fun for us just to reiterate. And as also another good number that continues to grow is the number of citations in the literature over the years, and we're now up to over 56,000 citations, and that's again just something we're always really proud of. And we honestly just want to thank all of our users for that. Today's webinar will be we will be utilizing the MP200, and that is the newest data acquisition unit that we have. It recently replaced the MP160, and it can be used with any of our amplifier series. So as some of you know, we have the C series, some of the C series pictured down below here. Those have kind of been our workhorse amplifiers for really over 30 years. So those are still extremely viable. We have a full series of the Bionomatics wireless modules that can be utilized with the MP200, and our newer D series, which are very much plug and play. They keep your footprint very small. They're automatically identified by the software and by the MP200, so it minimizes software within the setup in terms of everything like that. So it knows what's plugged in, your gain settings are already preset, your filters are preset. So basically the MP200 works with any of our C, D, or Bionomatics series amplifiers. Although we're focusing on Startle today, do know that we are a much larger systems integrator than just that, of course. So whether you're doing just the full gamut of biopotentials such as ECG, EMG, EDA, so on and so forth, or whether you're wanting to step into things such as larger, higher montage EEG systems or fNIRS, and even full turnkey out of the box, virtual reality setups. We basically have wonderful industry partners that we work with and integrate with, so it can really make life easy when you're trying to build out a larger lab that has several different modalities to it. For today, obviously, we are going to focus on Startle and Prepulse Inhibition of that a little bit, and kind of show you how to build out, ultimately kind of how to build out those files and to run the data related to that. And the Startle reflex involves basically a rapid activation of the brainstem circuits, especially the cochlear nucleus and the spinal cord. And although it's a relatively simple thing, as you'll see, it's a very simple hardware setup, and it's actually a quite simple subject setup as well. It's kind of one of those deceptively simple paradigms that really does, though, open up a window into the brain's ability to filter and prioritize sensory input. It's used across a wide range of different research areas, such as fear and threat, anxiety. For example, with autism, it can help researchers understand sensory processing differences and sensio-motor gating. For schizophrenic patients, it can often, they are generally characterized by a reduced prepulse interval, which can indicate impaired filtering of sensory input, and of course drug effects. And this can be used on actually both animal and human models. So a lot of times PPI is used to test how pharmacological agents affect brain function. So generally with Startle, we're going to be using an EMG amplifier. Some studies that you find throughout the literature might utilize EOG, but generally EMG is preferred. And it's a very, as I mentioned, which I will show as well, it's a pretty simple setup with 2 electrodes placed over the orbicularis oculi muscles. And we generally use EMG primarily because we're looking to capture the actual electrical activity of the muscle and ultimately wanting to look at the peak magnitude of that and the latency from when the startle happens, when the impulse happens, to when the blink reflex occurs. Now, prepulse inhibition is basically where we create a smaller stimulus prior to the larger, stronger startling stimulus. And generally with that, most of the time you're looking to see a reduced magnitude of the startle response. So you're going to ultimately in the EMG see a lower peak EMG response when a startle or when a PPI is induced or presented prior to the actual startle. In building out the file for the startle, which is what the first thing we'll do when we jump into the software in a few minutes here, is we're going to build, as you can see here, 2 different pulses. The first pulse, and this is going off of, kind of basically sticking along with most of the literature, we're going to have a smaller pre-pulse, generally in the neighborhood of about 20 milliseconds. And we're going to keep that one to somewhere in the neighborhood of 70 to 75 decibels, most commonly. We then have an interpulse interval of somewhere between 100 to 120 milliseconds. And generally with that one, it's going to be a little bit larger pulse, usually around 40 milliseconds. And we're going to keep that somewhere in the neighborhood of 100 to 120 decibels. And I'll talk about that a little bit more in terms of how we will need to test those as we build that file up. In terms of hardware setup, again, it's relatively simple. And we can utilize really any of our systems for this, the MP200, and of course, many of you will have an MP160 or even an MP150, and also utilizing the 4-channel MP36 system, both the research version of it with AcqKnowledge or the student lab version of it with the student lab software, with the BSL software. Any of the systems can be used for that. So in terms of hardware, that's all that's needed, along with an EMG amplifier. And it can be either the EMG 100C, the D series, or even the Bionomatics. I will say with the Bionomatics, because it is wireless, there is a delay, but it is a fixed delay. And that was when the Bionomatics amplifiers were created, they were built in with that in mind. So knowing that it's a fixed delay, you can adjust for that in the software, because of course in something like this, the timing is extremely important. So you'd want to adjust basically the EMG with that fixed delay and time it back a little bit so that everything is on. Because again, we're looking here at like millisecond timing. We're then going to be using our stimulator, which is our Stim 100C, which is pictured this central unit right here. We've got our headphones, and then again, as pictured here, that is the fEMG amplifier. And I think you might be able to see it here as well. So that right there is the actual amplifier. Beautifully small, super lightweight, really lightweight leads. You can just route them behind the ear, and honestly, the subject hardly even knows they have them on. And then this cable here, basically what we're doing here is we're feeding, this is the out 0. You have 2 analog outputs down here which tie into the stimulator. So every time the stimulator delivers a pulse, it's going to be fed through here and back into the amplifier, back into the AMI or the HLT, whichever one you have. And that allows us to record the actual auditory pulses that are going to be generated, of course. And in this, obviously with this, we're really going to only be dealing with audio in this case, but of course you can use various different methods. A lot of people will use like a tactile or mechanical method where they're providing like an air puff to the face to create the startle. You can use visual startle, of course, but in this case we're just going to be setting up and kind of focusing on simple auditory. If you did want to go a little bit beyond just simple white noise or clicks, that's where you would have to get into a little bit more in-depth setup utilizing SuperLab, ePrime, PsychoPy, anything like that, any third-party stimulus presentation system. And that allows you to create more unique sounds. You can go into different libraries of sounds, download those, whether it could be, horns honking, hand claps, doors slamming, different things like that. You can create audio files based on that, obviously feed those through the stimulus presentation programs, still mark the data. But again, that's just gonna, so whether you're doing different sounds or visual stim, that's where, SuperLab, ePrime, PsychoPy, Media Lab, something like that is gonna come in. But do know that those are absolutely all compatible with our system. As far as participant setup, that's basically what you're looking at right here. Just a simple ground electrode, generally on the forehead, 2 electrodes placed on the orbicularis. Obviously, you've got your headphones on. So again, it's a very simple setup from both hardware and software. In terms of analysis, which we'll also dive into, generally, again, a couple of the most common things people are looking to kind of extract from this data is the overall startle magnitude, which is ultimately going to be the peak amplitude of the EMG reflex. The latency, which is the time, of course, from when the stimulus is being delivered to when the blink reflex is occurring. And then they also might be looking at different things such as the probability of a response, and that could be based on utilizing different levels of sound. Again, like I mentioned, we're going to be dealing with primarily between 70 decibels for the pre-pulse and around 100 to 120 decibels for the startle. But sometimes you can vary that a little bit and look into more, where are you starting to see a response? If a response is maxing out, obviously a big part of that is if a subject is getting habituated to that over time. Because generally when you run these trials, you're not just hooking somebody up, pressing the button and giving them one startle. You're generally running this over 30 trials. So if they're coming into your lab and sitting down, they're generally running a trial which is going to run approximately 20 minutes or so if you're getting 30 trials with the spacing of somewhere between 15 to 30 seconds between each trial, between each presentation of the pre-pulse and the pulse. So generally a recording session for each subject is going to run between 15 and 20 minutes. I was going to kill my camera for this part just so I can totally maximize the software out. Okay. So basically and I'll explain what I'm doing here first before I actually build this out. But as I just mentioned, we're generally bringing somebody into the lab and running them through a trial that's going to last somewhere in the neighborhood of 15 to 20 minutes probably, because we're going to present generally in the neighborhood of 30 trials for one overall session. So once they get connected, headphones on and everything, they're going to hear a series of approximately 30, pre-startles and startles, and you're going to record the EMG over that entire period of time. So the first thing we need to do is to basically build what's going to be used as our Startle file, basically the auditory file, which is going to be run through the stimulator via AcqKnowledge as an arbitrary waveform. And I'll kind of explain all of that. So the first thing we need to do actually is to record, for the most part, just a flat line of data to work with. And the way we do that is to just, within AcqKnowledge, open up a graph file. And I'm actually going to trick the system a little bit. So we actually don't want to record any data, but it won't let you do that unless it does think that something is connected. So I'm just going to tell the system that we have an ECG connected, even though we don't. Just going to go with all the defaults, close that down, hit record. And as you can see, we're now recording just a nice flat line. There's different ways to do this. I actually prefer, if I know my trial is going to last 20 minutes, I actually prefer just to and that way you have everything you need to work with. You don't necessarily need to do that. You could just record, 60 like that, and then you'll see when we start cutting and pasting how that would be a little bit different. But I kind of think it's easier just to record the entire time session that you're going to need as a flat line like this. So obviously you don't want to sit here for 15 minutes while I do this. So we will stop that, and I'll close that down. And we will go back here to where we already have several minutes of data recorded. And so again, and what you saw there, it was zoomed into the nth degree, so it makes it look like a ton of noise. But once we zoom back out, you can see we've got a beautiful flat line. And now what we need to do is build the pulses for the pre-pulse and the actual Startle auditory that's going to be played through the stimulator. So to do that is kind of some tricks that can be helpful, because part of it is getting the correct resolution. Because ultimately we're going to be highlighting very, very small segments of data, obviously 20 milliseconds and 40 milliseconds. So we kind of need to get dialed into the right resolution. And I've done a couple things first to help with that. And so under my display menu and preferences, I have changed the number of my measurement boxes here. Generally, by default, when you open up AcqKnowledge, you have 5 measurement boxes that are open and available. Right now, I only need 2. So I've changed that number here from 5 to 2, and so that only these 2 here show up. Secondly, by default, AcqKnowledge usually reports the x-axis in seconds, and I've changed that to milliseconds. So those are 2 things that I've done that just help a little bit. The next thing to do is to zoom into kind of a nice resolution that makes it easy to, again, highlight data at the millisecond level. And instead of just using the zoom tool, I actually think it's easier just to come down to the x-axis. And I like zooming into a time scale of about 0.25 seconds, just like that. So now I'm going to, well, let me step back quick. So once we start playing this file, once we get it created and we've got a subject sitting down ready to go, again, this is ultimately going to be our stimulus file that's fed through the stimulator, which produces the audio clicks that they're hearing, both the pre-pulse and the startle pulse. You have the option in the stimulator to start this file, to start the playback of this file, either when data collection starts automatically or at any point in time once data collection has been started. So you kind of need to think about that on the front end on how you want to do things and what type of potential trial randomization you want, because any type of randomization needs to be built into the file. The software doesn't have the capability to take an existing file and just switch it up basically and randomize it. So if you're going to have subjects coming into the lab for multiple trials and you want randomization throughout each trial, you will need to build multiple multiple stim trial files such as this. So let's just say, for example, we want the first pre-pulse to start right at 10 seconds. So I will position my screen here. You can see the 10-second mark there. I want to click on my I-beam tool, click on right around 10 seconds. So you can see here, this is why I have the time selected. So you can see I'm right up almost 10 seconds. If I want to get exactly on, I can use my arrow key, go over 1 notch, and I'm right at 10 seconds. Now what I want to do is hold my shift key and just using my arrow key, because again, it's to point, click, and drag with your mouse and get right on 20 milliseconds is really tough. So it's much easier just to use your shift key and your arrows. And as you can see now, as I go up, my delta t, which is my time along the x-axis, is changing. So basically hit that 10 times, actually 20 times, because I want 20 milliseconds. Boom. So I've got 20 milliseconds highlighted perfectly. Now we go into transform. We're going to do waveform math. And in this case, we're just going to add a constant. And we're just going to put 7. And boom, now you can see we've got that pulse. Now I will say this, just because we put 7 there, and that's a 7 millivolt pulse, that does not by itself equate to 70 decibels. I'm just using that because I like that number in my head, basically. So I'm going to do 7 for the pre-pulse and 10 for the actual pulse. The actual volume of this will be controlled by the stimulator itself. And there's a volume knob on the stimulator. So once we have this created, we would need to utilize an auditory, a monitor, a decibel monitor, and figure out where the volume control needs to be to get things dialed in terms of the volume. So now I am going to jump ahead another 120 seconds. So I need to find basically 1,000. Where are we at? Right there. And I'm going to highlight 40 milliseconds. Go back to transform, waveform math, hit 10. So now we have our pre-pulse and our startle pulse. Now all we need to do is highlight these. Hit edit, copy. We're now going to rescale. I'm going to scale down to about 10 seconds. So now we can see more of our overall, what's going to be our stimulus file. And now this is where I need to create the randomization. So I want to place these, and again, this is going to be up to you to define. But generally, according to literature, you want an trial interval of somewhere between 15 and 30 seconds throughout the entire trial. So basically what we would do, if we know this one started at 10, if we want to jump ahead somewhere around 15 seconds, we're going to be looking somewhere in the 25-second neighborhood, and that's where this time comes in here. We know exactly where we're at. And again, we can just hit Control V and we just paste that in. So basically we just move ahead in the data file and put our pulses wherever we want to in terms of potential randomization. And I won't go through the whole thing here, but if I hit Control H now, you can see what we started to build out. And so once that's done, again, this is the file that's going to be played through the stimulator. So that's kind of the next step now. So if we say we're now bringing a subject into the lab, we're going to open up oops, I'm sorry. We're going to open up a new graph file. Now I do want my amp plugged in, a new graph window. I've got my EMG, my FEMG 100D plugged into channel 2. On the analog side, I am going to enable the first channel on my HLT because, again, I want to record the impulses coming from the stimulator back into the software along with the EMG, and this will allow for that. Sorry, it's going to list it as a custom. And now we need to go into the stimulator settings. So again, we have several different webinars that really dive in depth to the stimulator. In this case, the only thing we're going to be focusing on is utilizing an arbitrary waveform, which is this icon here. So once we click on this, we want to turn the stimulator on to where we'll output once. And basically what that means is now you can see our file up here. So this is the stim file that we created. AcqKnowledge has now loaded that as an arbitrary waveform. Once we hit the start button to start collecting data, it's going to play through this entire trial one time, and then it will stop. It won't continue to like start again and replay. And it's going to start immediately when we hit the start button. So we don't need to do anything else. Once we hit start to record data, that's all we have left to do. We can let the trial run in full, and once we're done, disconnect the subject. So I can close this. Well, one other thing we do want to do is change this sample rate. So data right now is being collected at 2,000. The EMG data is going to be collected at 2,000 samples per second. We want to make sure this is set to the same level. If this is set too low, because we're running such small pulses, especially the shorter 20 millisecond burst, if you don't have a high enough sample rate, the software actually won't capture it. It's easy. It doesn't have that resolution, the high enough resolution to capture that. So it is important to set this at the same rate. We'll hit close. And then if we hit start, I'm going to change my x-axis. So again, right now we don't have anybody hooked up, of course, because we can't just sit here and watch somebody blink for 20 minutes. So what's coming through the EMG is obviously just noise. But up above, you can see our pulses coming through. And just like we created in our file, the first one started at 10 seconds. The second one hit around 25. And so now this is where we would just basically sit back, let the subject go through the entire trial. And once it's done, that's then disconnect them. And again, bring the next subject in and so on and so forth. So of course, once data is collected, the next big thing is to jump into the analysis of it. And so let's look at an actual trial here. So now here we have the full trial up above, the stim channel up above, and an actual EMG down below. And so the question is, of course, if you have run 50 or 100 subjects through, and especially if you brought them back multiple times, so you might have 5 trials on each subject, as you know, the largest part of your time burden generally becomes the analysis. And having somebody step through each of these files by hand, one by one, obviously can be extremely time consuming. So there's a huge benefit to creating a workflow for this, which can help with that and help automate it. And with any automation, of course, you can only take that so far. There's always the point to where you're going to have to put eyes on the data to make sure that what you do set up, whether you're doing it by hand or whether you've automated certain things, that it is performing correctly and basically marking things that you want to mark correctly, extracting the measures that you want to correctly, so on and so forth. So you can never just, at least in my estimation, you can never just blindly create automation and just trust it innately. To me, you've always got to put eyes on the data to make sure that things are being properly done. But to kind of start working through the analysis on this, I've created a workflow. So I'm going to open up my workflow editor. I'm going to open the existing workflow that I've created and kind of walk you through what we intend to do. So as I mentioned previously, a couple of the key measures that people look at are the amplitude of the EMG, the peak amplitude of the EMG response, and of course the timing, the latency, which is the timing from when the startle pulse occurred to when, again, the maximum EMG response occurred. So to do that, we need to do a couple things in the file first. We do want to filter the EMG, we want to integrate the EMG, and then we need to mark the peaks of the EMG, the peak EMG responses, and we need to mark the peak of the stimulus pulse. And then we can extract measurements based on those. So to do that, we're going to create a workflow so that we don't have to do it by hand every time. And if you're not familiar with workflow, it basically is queuing off of the transformation and analysis menus within AcqKnowledge. So you do need knowledge, you do need a good understanding of those menus and the different functions that are available within those menus. But whether you're doing it by hand or whether you're using workflow, the truth is you need to know how to use those menus in order to analyze your data. So the benefit with a workflow is you kind of only have to do it once to some extent. And so basically it's a GUI interface where you just drag and drop the different commands that you want it to do. So for example, the first thing we're going to do is go into the file management and we're going to ask it to find the graph that we want to work with in this case. And so I basically click on this, drag it over, and this is what shows up here. The next thing we want it to do under graph management is we want it to then open the graph. So I click on this, drag it over, and it adds it, and so on and so forth. So what we then want it to do is we want to change an active channel. And the nice point about this, if you're not sure what to do or like what menu it falls under, you can click up here and type in whatever you want. Let's see what we're looking at, like. Well, I've got it right here. Okay, sorry about that. So basically by clicking on these, you can see all the different functions that are available. And so if you know what to type, it'll bring it right up. So we've got basic transformations, digital filters, Fourier, math, for example. And so again, having a good understanding of what is needed for each one of these is necessary, but once you kind of know what it is, it makes it quite easy when it's all said and done. So right now we are going to go into, again, channel adjustment. And after we've chosen our file and opened our file, the first thing we want to do is make sure that we're set on the correct channel. So we're going to change our active channel, and we're going to change it to channel 2, which is the raw EMG file. The next step we're going to do is duplicate that. So again, we've changed the active channel. We're now going to duplicate the active channel. And the reason we want to duplicate it is because we always want to keep the initial raw EMG data intact. So if we're filtering it, integrating it, so on and so forth, if ever we need to go back to the raw, we want to make sure that we have that intact. And so we're going to duplicate that channel first. We're then going to change the active channel to the new duplicated channel, which will be channel 3. And then we're going to select all of the data in that channel. We're then going to apply a digital filter fixed at 60 Hertz. We're then going to, again, make sure that all the data is selected. And we're then going to integrate that data with a moving average of 200 samples. We're then going to auto scale it, and that's basically just for visual effect to make sure that everything is seen, that we can see it visually. And then we're going to go back again and change the active channel to channel 1, which is our stimulus channel, this channel here. And now we're going to jump into the fine cycle routine. And if you're not familiar with the fine cycle routine, it's one that I definitely encourage you to get familiar with, because there's so much you can do with it. I think we have 6 or 7 different YouTube videos that focus just on the fine cycle routine, because there's just so much functionality to it. So what we're going to do here, and it can help, and do know that when you're building this out, this is not something that's going to come together in 30 seconds. I spent quite a bit of time on this, getting things dialed in. And one of the ways to do that is I do jump back and forth between the workflow and actually doing it under these menus, because certain things don't show up when you're doing it in workflow, for example. And I'll show you what I mean by that. So the first thing we want to do is mark the peak of this point right here, basically the peak of all of the startle responses. So if I go into analysis, fine cycle, I want to locate cycles from peaks in the data. Those peaks are positive, of course, and the threshold that we want to use is going to be anything above 7, basically, because our pre-startle pulse, we know we used a constant factor of 7. So anything above that is going to avoid tagging those, and it's going to tag the actual startle response. So if I put in 8 or 9, as long as I don't go past 10, it's going to find, it's going to find all of those. And you can see those marked here. Hopefully you can see them. They show up in light blue, like right at the peak. And this is helpful when we build it out, because we know we're identifying things correctly. When you're in workflow, it doesn't kind of show those visual cues to you. So sometimes it is helpful, I think, to jump out of workflow, create it on the menus itself, and kind of make sure that the settings that you have here are correct. The next thing that we want to do then is actually output events at the peak of the workflow, and we're just going to output it at the maximum. And so if we jump back into the workflow, that's precisely what we've done. We've gone through, we're going to locate the cycles from the peaks. Again, they're positive. The threshold is 8, and the output is going to be events. And we're going to mark the peak of each startle stimulus with a long arrow, and we're going to mark it on the channel itself. Next, we're going to jump down. We're going to change the active channel back to channel 3, which is going to be, you don't see it here yet, because it hasn't been created, because they haven't run through this yet. We're going to run back to channel 3, and now we're going to find the peaks in that. And this again is where you have to do a couple things beforehand, because you do need to know this threshold level. And without running it through prior, you actually won't know the threshold. And this is probably where it would keep you from, the beautiful thing about workflow, it saves a ton of time. And if you have, it can do obviously large batch processing. So if you have 50 trials from 10 different individuals, for example, and it's all saved in one folder, you can direct workflow to that folder and cycle it through to where it opens the folder, finds the first file, runs through this in its entirety, saves it, goes to the next one, and just boom, 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 right after the other. And you're just sitting there watching it. It's a thing of beauty. But there's certain things that sometimes, across participants, across different trials, things can change. And one of those things are the thresholds. And so when you're doing the startle analysis, this is probably the key factor that would potentially keep you from just being able to do like a large batch process, because you do need to know where this cutoff is. and go in and kind of pre-identify it and play with the file to see where that threshold is and what you're happy with. And that's why I kind of prefaced things earlier by saying it is always important to get eyes on the data to make sure that what you're trying to call out of the data and extract from the data is actually being extracted. And then once we find that threshold and we're happy with that, we're then going to output, again, an event. In this case, we're going to mark it with a flag. So we're going to mark the peak amplitude of the EMG responses with a flag. We then go back into Find Cycle, and we're going to identify the two events that we just created, which is the flag, which marks the peak of the EMG response, and the long arrow, which marks the peak of the startle. And from that, our output, we're then going to output different measurements. And the only two we're going to look at right now, we're going to look at channel 3, which is going to be our integrated EMG. We're going to look at the maximum, and then we're going to look at the delta time, which is going to pull out the delta time between those events. And so if we step through this now, let's actually step through it. I'm going to close this file down. And the nice thing about workflow is we can kind of test it. So we can use this button here. This is going to play it through in full, but this runs it step by step. So I'm going to click on that. It's going to ask me which trial do I want to use. We're going to use Stim Trial 2. The next step is to open it. So you can see it's now open. Let me maximize this here. Okay. We're then going to change the active channel. So we've made the EMG down here, the active channel. We're going to duplicate it. So now we have our duplicated EMG, which is now channel 3. We're going to highlight all of the data. We just filtered it. You can see the difference now between the initial raw data and this is the filter. They're going to, again, make sure that all the data is selected. We now just integrated it. We rescaled it. We're now going back and changing the active channel to channel 1, which is the stimulus channel. We've marked the peaks of the startle. We're changing the channel back to channel 3. We're marking the peaks of the EMG responses with flags. And now it's going to extract the measurements. And it's just asking me here if I want to create a journal, which I do. And so by default, it's going to not only create a journal and paste the measurements in the journal, but I also asked it to create and export the measurements into an Excel file. So that's kind of stepping through it step by step. Let's go through and kind of run it in full without, just so you can see in reality actually how fast it does run through. So I'm going to close this out again. And now instead of doing the step by step, I'm just going to run it, choose my trial. And just like that, we've got our data. So you can see just once you've put the time into building the workflow, you can see how much time that can ultimately save. And of course, once data is in AcqKnowledge, once data is in Excel, that's where you can do further analysis, in terms of averages and comparisons, and basically prep the data for more higher level statistics. Again, you do need to obviously put eyes on the data. There can be areas and instances to where you might need to get rid of a marker or get rid of a flag. we only want responses to stimuli. And obviously, although you instruct the person not to blink as much as possible throughout the trial, hoping that they will only blink when a startle is presented, there are going to be random eye blinks. And if some of those reach the threshold that we've set, those are going to be marked. But if you don't want those included in the analysis, then it is necessary to potentially go back and delete some of those or correct some of those. So again, that's where I always caution people that as beautiful as workflow can be in terms of saving time, there's always a necessity to put your eyes on the data and actually dig in and just make sure that things are accurate to ensure that the data being extracted is accurate, because ultimately that's where analysis is going to come from. So with that, we can jump back to Brenda for our last poll and maybe some Q&A.
Okay, so let's just go ahead and launch this poll. Thanks, Tim. What modality are you using for your startle? And then are interested in using, I guess you could say, as well. And then we do have one question from Brianna. Can the hardware be used with fNIRS?
Yes, of course. Yeah, you can use, again, you don't have to be limited to just the blink reflex. You can have any number of sensors connected, but when we're talking startle, generally, the blink reflex is the most used modality, but you can absolutely use other things, whether it's EEG or fNIR. But yeah, so absolutely. The one thing you do need to keep in mind with that is, the blink reflex is an extremely quick reflex. So you're generally looking in the neighborhood of, several milliseconds, whereas the fNIR signal is a slower signal. So you're not gonna, your responses are gonna, I guess, be delayed, but as long as you know what to expect in terms of that, it could still be used. You'd probably just have to adjust your inter-trial interval to give the subject a bit longer to return to kind of normal stasis before presenting the next series of pulses.
Okay. Well, thank you very much. And thanks, Tim, for putting all this together. I'm going to pop back over to my screen. You didn't have anything else to show, right?
No, that basically kind of wraps it up.
Okay, that's what I thought. All right, well, let me pop back over to my screen. And the great majority, just so you know, the poll results, the great majority of people are interested in auditory startle. So yeah, so that was a good topic, I guess. All right, well, I just want to let everybody know that we have live webinars almost every month of the year. Our next one is coming up on September 25th, Practical Neurophysiology, Recording Nerve Reflexes and Conduction. And what I like to do at this point is just pop into our website and just show you where you can go, biopac.com/webinars. We have over 100 webinars here. I think we're almost to 120 or 125 now even. Lots of great topics for you to explore. You can go back and watch these at any time, whenever it's convenient for you. Also, we have guides and application notes and videos. In fact, since you were talking about fine cycle detector, if you go to our support section, you can go to video tutorials here. And then if you click AcqKnowledge, it'll teach you about fine cycle peak detector here. There's lots of great videos and training information on our website. And then Brianna, I know you asked about fNIRS. If you just type fNIRS or any product, any signal up in the top right-hand corner, you can get more information about the types of things that we offer. Anyway, I'm going to pop back into my presentation here. Let's see, I have to do this. Okay, right. All right, well, just also want to let people know that we host, we can come to you with the equipment. I know we go to conferences throughout the year and you can come visit us at the booth. We're going to be at Neuroscience this year. But if you have an interest, our regional representatives can come visit you at your location. Also, you can invite other people. We can do a whole workshop. We've done that at locations all over the world. You can get your hands-on with the equipment and really understand. It's longer than a webinar, so you can do like a half day or a full day or a multi-day workshop, and you can invite colleagues from your institution or your regional area and make it a day. It's a really cool way to see the equipment and really understand how it works. Okay, and then I just want to let everybody know. So first of all, thank you, Tim, for putting all of this together. I know it's a lot of work to put these trainings together, so thank you for your time and for helping us out, and thank you to the audience for being engaged. Today's webinar was recorded. We'll email you a link of the recording and the slides that we have. When you close the GoToWebinar window, you'll see a survey. Please complete that so we have your feedback and ideas for future webinars. Also, if you have a topic, if you have some interesting research that you would like to present on using BIOPAC equipment, then we'd be happy to talk to you about that. We're always interested in hearing from our customers about how they're using the equipment, but also like the interesting research that they're doing. It's always great to present that. We've presented on mindfulness and dyadic research and all kinds of things. So reach out to your local representative if you're interested in that. You may visit biopac.com for additional references, including screencasts on specific features, analysis tools, application notes, and information about upcoming events and webinars. Tim, is there anything else before we conclude?
I don't think so, not unless there's another question or two. So
yeah, I think you covered it really well. So I think we're just going to go ahead and complete the webinar before the end of the hour, which almost never happens here at BIOPAC. Usually we go way over. So thank you again, audience members. Really appreciate your time this morning, or wherever you are in the world, if it's afternoon or evening for you. Appreciate you joining us today. This concludes today's webinar. Thanks, everyone, and goodbye.